Electrochemistry, pages 289 to 292, focusing on voltaic and galvanic cells. Batteries are called voltaic cells or galvanic cells and are constructed from spontaneous electrochemical reactions. When the reactants are together in the same container, electrons are exchanged between the reactants and the excess energy is lost as heat. In a battery, the reduction and oxidation reactions take place in separate containers. The electrons flow through a wire and can be used to perform electrical work in the surrounding. Here's a diagram where the reaction is happening in one container, and as the reaction occurs, the energy is lost to the surroundings as heat. But if you separate the oxidation and the reduction parts of the reaction, then the flow of electrons lost by oxidation would move through a wire and then to the reduction part of the reaction where they are gained. And then these electrons, this flow of electrons, can do electrical work on the surroundings. Let's investigate how this reaction can be used to make a battery. So you have solid zinc, which is neutral in charge, and then that changes to zinc plus 2, which is the oxidation part of this reaction. And so we're going to lose electrons from the zinc metal when it forms aqueous zinc, and those electrons that are lost are going to be gained by the copper 2+ ions, which change from +2 to 0, which is a reduction. So gain electrons reduction. So here we're going to lose the electrons from zinc, and they're going to be gained by the copper, and then we can have a flow of electrons to do electrical work on the surroundings. Let's see how this looks in the form of a battery. So here's my equation once again, and the oxidation part of this reaction is zinc 0 to zinc plus 2, which I have written here. There's the half reaction. Electrons are pushed from the oxidation part of the reaction to the reduction part of the reaction, and they flow through a wire which is used to power this light bulb. You can think of the battery as an electron pump, pumping them from one side to the other. The left side is the anode side where zinc is being oxidized. So notice it's been labeled the anode. You can actually remember this because oxidation occurs at the anode, or O and A are both vowels. On the right side, the cathode side is where the copper is being reduced. And so you can see this is marked cathode, and this is where the reduction is occurring. And one way to remember this is red cat. Reduction occurs at the cathode. Notice that electrons are pushed up the wire from the oxidation side, and they are pulled down the wire and consumed by the reduction side. The force pushing the electrons is called the voltage, and so that would be measured somewhere in this area right here. You would see a voltage, or the electromotive force, also known as the EMF. The ions complete the circuit, and so you'll notice we have some ions, and those are generated by what's called the salt bridge. And in this case, this is the salt bridge or salt membrane. They complete the circuit by carrying the charges in the solution. Negative ions flow toward the anode, so negative anions flow toward the anode, and positive ions flow toward the cathode, or positive cations flow toward the cathode. Notice the similarities in the names. Anions go to the anode, cations go to the cathode. That's actually how cations and anions got their names. Because the zinc is changing into aqueous ions, we expect the zinc electrode to decrease in mass. And because the copper +2 aqueous ions are taking these electrons and forming into the solid copper electrode, we expect this to increase in mass. So a voltaic cell is an electron pump that can generate electricity from spontaneous redox reactions. The reaction at the anode is where oxidation occurs, and the reaction at the cathode is where reduction occurs. Pause the video and copy down this diagram of a voltaic cell, and keep in mind that a large part of your final unit is going to be actually labeling all the parts of a voltaic cell. So spontaneous electrochemical reactions allow us to create a battery. Oxidation and reduction occur in separate containers. Electrons flow through a wire where electrical work is performed on the surroundings. Notice the electrons are always going to go from the oxidation side to the reduction side. So from oxidation to the reduction side, or from the anode to the cathode. And one way to remember that would be FAT-CAT, which stands for from anode to cathode, which describes the electron flow. Note that when we lose electrons, oxidation occurs at the anode, and when we gain electrons, reduction occurs at the cathode. And remember, we had the red cat that could be used to remember that reduction occurs at the cathode. The salt bridge, anions are going to flow toward the anode and cations are going to flow towards the cathode. The voltmeter, or EMF, measures the flow or the electrical current. In the anode, the mass should decrease because the metal is forming into aqueous ions, and so that is the reason why the mass decreases. Here the mass is going to increase because your aqueous metal is forming into solid metal.